So we're going to show some more priority groups right now. All of these are oxygen-containing priority groups. And remember the example, the thing that I said about the CEO versus the regional director, so on and so forth. All of these are more important than the alkene. Every one of these that I'm showing, I'm not showing you all of chemistry right now, not at all. There's tons of different priority groups. But my idea on this is, if I show you how to work with a couple of them, then I could just give you a longer list and you could just expand what you're doing. It's the same exact idea. So the priority here is going to be a little table. So make sure you have enough room on your page to create a table. It's going to have like 1, 2, 3, 4, 6 parts, I think. We're going to put this in an order. This way is going to be increasing priority. So in this list, what's lower down is more important than anything higher up. So you know what should be the highest position for what we've learned so far? Alkene, because I said alkene is less important than anything on this list. Right? So it'll be alkene and then this list. It's not really a big list. I'm going to do a group after the group. After the group, I'm going to draw a symbol for the group. After the symbol for the group, I'm going to draw an example. After the example, I'm going to write the name for that example. And then I'm going to explain what I did with the name, which is I'm going to show the suffix, and that's if top priority. But then I will also point out that if that group is in the chain with another group in the same chain, that the one that's lowest down on this list is the top priority. So because of that, you can't give a suffix to not the top priority, so the group that's not the top priority just becomes a substituent. And you give it a prefix. Trust me, you'll understand this in a few moments. Just try to stay with me here. Prefix if not top priority. So what's the first group? It's an alcohol. Remember, these are oxygen-containing priority groups or functional groups. The first group is an alcohol. The next group is a ketone. The group after that is an aldehyde. And the final group on this list is a carboxylic acid. Raise your hand if you're awake and alert. This is good. Some of you might want to raise your hand. Maybe now, maybe in like, I don't know, 5 minutes or something, and challenge, not challenge me, but like ask the maybe burning question, because those of you that know what each one of these functional groups look like, and I think you should know what they look like, they're in chapter 1, you should memorize what these groups look like. If you have a picture in your head what these two groups look like, you might think, did you mess up the order? Because an aldehyde has a hydrogen in some spot, and a ketone has a carbon chain there, and it feels like the ketone is more important than the aldehyde. I did not mess up this order. So I'm letting you know ahead of time what a good student would ask, somebody that already knows stuff, that read about this beforehand. If you don't know what I'm talking about, that doesn't make you a bad student. You're just a little less prepared, and that's not the end of the world. When I show you this, you know how where the priority comes from, where the importance comes from? It's actually coming from oxidation state. So if you take a look at the oxidation number for the carbon that the alcohol oxygen is attached to, This is less oxidized than an aldehyde or a ketone. An aldehyde and ketone is more oxidized. These have about the same oxidation state, and the most oxidized is the carboxylic acid. And between these two, between ketone and aldehyde, how do you differentiate what's more important if they have basically the same oxidation state? It should be sort of meaningless to you, because we're really going to discuss oxidation states more in orgo 2, in the beginning of orgo 2. But just to have you and I have an idea of how they came up with what's more important, what's less important, the way that you broke down which of these two are greater importance actually is going to be found in chapter 16, which that chapter is on ketones and aldehydes. You're going to find out that the aldehyde is more reactive than the ketone. And if you have a chain, and on that chain there's a ketone, and somewhere else on that chain is an aldehyde, it'll be doing more aldehyde chemistry than it'll be doing ketone chemistry. So then what would you call the whole thing if you had to give it a name? Is the whole thing a ketone, or is the whole thing an aldehyde? Doesn't it behave more like an aldehyde? If that's true, if what I just said is true, that an aldehyde's more reactive than a ketone, then what would you call it? You'd just say, well, it's basically an aldehyde with a ketone on it. It's not a ketone with an aldehyde on it, right? Okay. What is the symbol for an alcohol? It's ROH. We use the letter R to say that there is some carbon or carbon change. So R can be a CH3, a methyl or an ethyl or a propyl or a butyl, right? What is a ketone? A ketone is R, carbonyl, and then I write R, but I'm going to write a prime over here for that second R, just to denote that this R does not have to be identical to this R. They could be different R's. Following? The aldehyde has an R. Well, actually, there's two versions of the aldehyde. There's H, carbonyl, H, or R, carbonyl, H. There's obviously only one molecule that fits this description, and there's infinite number of molecules that fit this description. Right? But what's the point? A carbon double bond O is called a carbonyl. A C double bond O, I'm not drawing in this box right now. This is not carboxylic acid. I'm just side note. A C double bond O is called a carbonyl. It is pronounced carbonyl, which is weird. I understand how anyone will want to pronounce that carbonyl, because don't you call it methyl and ethyl? So you call it carbonyl, right? But no, it's called carbonyl. And probably mispronounced, but it's mispronounced by the people who sort of named it, so like, might as well mispronounce it too. Now the carbonyl carbon is connected to things, has to have 4 bonds. If none of these are a hydrogen direct connection, if these are some kind of carbon chain and some kind of carbon chain, that's a ketone. But if one of them is a direct connection to a hydrogen, then it's an aldehyde. All you need is one of them to be connected to one side to have a hydrogen, and that's an aldehyde. So if both of them have hydrogens, then it's also an aldehyde. It's just a specific aldehyde. This aldehyde is called formaldehyde. What is formaldehyde used for? It's a horrible poison. It is a horrible, horrible poison, and it kind of kills life. So because it kills life, it's used as embalming fluid in a biolaboratory. You can have a fetal pig or some kind of thing like that you're dissecting a frog in that fluid, because it'll kill off life. So bacteria can't go in there and decompose the frog, right? So would you want formaldehyde in your system? Like, I mean, if you were a mummy and wanted to stay preserved, then perhaps formaldehyde. There is a drug, no longer is this a problem, but like 30, 40 years ago it would have been a problem. There was a drug called angel dust that has a street name, used to have a street name, formaldehyde. For some reason they also call that formaldehyde. People died. They're in there, there's like, you know, college, experimenting with drugs, right? So you're sitting in a biolab, and you get a fetal pig, and they say, yeah, it's in formaldehyde. And suddenly the drug addict, I wouldn't call it a drug addict, you're in college, right? So you're not like a crackhead, but you're experimenting, right? You're in college. So the experimenter of drugs in college is like, whoa, formaldehyde, I heard that's angel dust. So they like dip something in there to take it with them because it's a liquid, dip cigarettes in there, and then they smoke that and die. So just so you know, the street name formaldehyde has nothing to do, at least I don't think, has anything to do with this actual formaldehyde. Before I continue the table, I want to show you something. to really figure out the difference between ketones and aldehydes. Imagine I had this chain right? The real difference between, I mean, this one is called formaldehyde, but every other one has a chain with a carbonyl. The difference between ketone and aldehyde is really positioning of the carbonyl. Think about this. Where would it be if it was a ketone? Could it be over here if it was a ketone? If I put a carbon double bond O over here, is that a ketone? That would have a carbon on that side, and then look, you only see 3 bonds, so obviously there's a hydrogen on this side, so that's not a ketone, that's an aldehyde. So here's the quick way to say it. If it's at the end, if the carbonyl is at an end, it's an aldehyde. And if it's somewhere more internal, then it's a ketone. Aldehyde or ketone? I'd like to hear the whole class. Aldehyde or ketone? Everyone said aldehyde. Aldehyde or ketone? Ketone. Everyone said ketone. Aldehyde or ketone? Aldehyde. Aldehyde or ketone? Illegal. You can't have 5 bonds on carbon. That carbonyl can't exist because a carbonyl can only have 2 things. Do you see whether it's this one, or this one? It's only 2 attachments. Just trying to make sure you're awake. Back to our table. Tomorrow's going to be a fun class. I'm going to have to rush through everything I did today because today's lesson should be over in 5 minutes, but it won't be. Don't worry, not too much after that. But so what is this? Carboxylic acid. That has this group. It's a C double bond O and an OH. Do you see it's sort of like everything that you have above? It's got a carbonyl and an alcohol on the same carbon. And then, of course, there's an other bond. There's another bond. Now, that bond can be to a hydrogen, like an aldehyde, or it could be to a carbon group. So there is either this kind of example of a carboxylic acid, or you would do this formula for a carboxylic acid. Do you see? It could be like carbon or longer, right? This one, by the way, you call formic acid, and I think I've explained that formic acid is the stuff that red ants stink you with, that burns, right? So what's an example of an alcohol? I'm going to use like a 5-carbon chain. I'm going to drop an OH somewhere. Here it is. What's an example of a ketone? Sticking with a 5-carbon thing, I'm going to drop a carbonyl somewhere. Where can I not put it to be a ketone? On the ends. Where should I put it? Somewhere more internally, like over here. How about this? Aldehyde. Sticking with a 5-carbon thing, I'm going to put the carbonyl on one end or the other. And sticking with a 5-carbon theme, I'm going to put a carboxylic acid over here. What is the name of this? 2 ways to name this. You could name this 2-pentanol, or you could name that pentan-2-ol. Do you see that's a lot like I showed you how to name the alkene? Like if I had a double bond, I could call it, let's say, 2-pentene, or I could say pentan-2-ene. It's the same thing. I'll break it down in a second. What do you call this? This will be called 2-pentanone. I don't like that as much as I like pentan-2-one. Now I will admit this one looks weird. When I write pentan-2-one, it looks like it reads pentan-2-one. It's not one, it's own. That's just how it goes. I like this better, I like this better, and we're not leaving here until we are convinced that this is better. But in order to convince you, I have to mix functional groups. I have to give you a chain with an alkene and an alcohol, and then ask you how you would name it, and then you realize there is a better way. What do you call this? You call this thing pentanal, and I'm not going to call it 1-pentanal or pentan-1-al for one simple reason. Let's remember redundancy. Over here, if I have 3 carbons and a double bond O, what do you call this? So if you are kind of getting the feeling over here, that's internal carbonyl, That's a ketone. It's a 3-carbon, so it's propane, right? Propane, do I have to give the position of that carbonyl? The answer is absolutely not. There's only one place it could go if it's a ketone. So I'd call this propanone, right? Do I have to give a position over here? If it's an aldehyde, it would be called propanal. So why am I giving a position over here? Because how many ketone isomers can you make out of this? If I put the carbonyl over here, from this side it's 2. If I put it over here from this side it's 2. If I put it over here from that or that side it's 3. So there is a 3-pentanone and there is a 2-pentanone. Those exist. Do any other pentanals exist? If it's a 5-carbon aldehyde, your choice is putting the carbonyl on this carbon or putting the carbonyl on this carbon. No matter what, it'll be called 1-pentanal. So what's the point of putting the 1 in if it can only be 1-pentanal? Yes? Whenever it's an aldehyde, so the question was whenever it's an aldehyde, and I cut the student off before she continued. If it is an aldehyde as the top priority group, aldehydes don't get numbers. Now it is possible that you have an aldehyde in the same chain as a carboxylic acid. No longer is aldehyde a top priority group, you're going to have to give some numbers, right? Carboxylic acid has the same deal, same idea. You call this 1, 2, 3, 4, 5 carbons, pent, and then instead of the letter E, you write oic and give it a space, acid. For example, acetic acid, benzoic acid, pentanoic acid, right? In fact, acetic acid is this, but based on our, that's acetic acid, right? But based on our nomenclature right here, you could call this something else. Instead of calling it acetic acid, you could call it for 2 carbons, ethanoic acid. Are you witnessing? Okay. The carboxylic acid is such an important functional group, such an important priority group, that it's the first one that gets a space in the name. After oic, you put a space, and then you write acid. Because this is going to be the top priority based on everything we're doing, of course you're going to give this the lowest number you can give it, which is the number 1. It doesn't matter what else is on the chain. So it'd be very redundant to write 1-pentanoic acid or pentane 1-oic acid because it gets the number 1 since it's the most important group. What did I do in all these cases? I drop the letter E. Didn't I do that? Look at the name. Instead of pentane, it's pentanol, right? So instead of A and E, it's OL. I drop the letter E and I add ol. Over here, I drop the letter E and I add ONE. Over here, I drop the letter E and I add AL. If you really stop and analyze this, this is a little ridiculous. The name of alcohols ends with all. The name of ketones end with -one. The name of aldehydes end with not hide, but al. I didn't make it up, I'm just delivering it. Right? I don't know why they chose al instead of hide. Right? Whatever. The name of ic acids ends with ic acid. So over here you drop the letter E and you add oic acid. I once had a student, when I wrote down drop E, add acid, I had a student blurt out, "That's what I'm talking about." And I'm like, come on. I don't mean drop the drug E and then follow it by LSD. That's not what I'm talking about. Drop the letter E. Okay, what happens if you have a chain that has 2 things in it? Like imagine you have this. You have this chain, same thing we're looking at over there. You got a carboxylic acid, and then you also have an alcohol. There's only one boss. There's only one boss. Who's the boss? The carboxylic acid. So I'm going to circle the parent chain. Here's the parent chain. Notice I've circled including the carboxylic acid group, and I number it for the boss. 1, 2, 3, 4, 5. So who is this? It's not an all anymore. It is some sort of substituent, and it is not more important than a methyl, an ethyl, or a chloro. It's going to get alphabetized. But what's the name of that substituent? That goes here. If the alcohol is on a chain and it is not the top priority group, and what you call this is hydroxy. Pick up a shampoo bottle or some kind of, like, I don't know, ingredient, and you'll see stuff like alpha hydroxy blah 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 oil. Rather than blah blah blah, have some words, right? All the hydroxy means is a hydrogen and an oxygen, hydroxy. That makes sense? If you have a ketone, imagine you have a chain that has alcohol, ketone, aldehyde, and carboxylic acid. Again, the carboxylic acid is the only one that's important, top priority. Everything else is going to be a substituent. So what do you call a ketone that's a substituent? You call it oxo, because there's only an oxygen there, so you call it oxo. Get ready to dislike the next one. You ready? You call this oxo. I know. But how do you know? You'll know. You'll know how you know. You'll see. Could this be a substituent? Let's say that's the most important group in all of organic chemistry. Could that be a substituent? Yes, it can. Yes, it can. Here's how it can. A parent chain can only have two ends. So what if you have branches and each of them end with carboxylic acid? Like, for example, let's say you have a carboxylic acid here, let's say you have a carboxylic acid here, and let's say you have a carboxylic acid over here, right? And the parent chain can only include two of these. It can't include three of them. So the parent chain will go from 1, 2, 3, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Any one of these five is from end to end. Do you see that's a primary carbon, that's a primary carbon? So this thing has to be a substituent because it's no longer part of the parent chain. It branches off the parent chain. What do you call a carboxylic acid group that is not the top priority anymore because it's like on the side or something like that? You call it carboxy. Because it's a carboxylic acid, carboxy. Now there's another way to name these, and I don't like it, but I'll point it out. Some nomenclature systems call it keto, and some nomenclature systems call this aldo. But you don't need to do that. Like, when you read keto and aldo, you'll know what's going on over there. But if you memorize the keto and aldo, you will have no idea what's going on when it's oxo. So I wanted you to learn the oxo. We will pick up from this table next time. Bring the table with you. We're not done. We're not done. I have negative 7 minutes. We're not done. I just want to point a couple of things out. If you've been paying attention, what do you call this? It's 1, 2, 3, 4, 5 carbons, so it's pent. And you number it for the lowest number 1, 2, not 1, 2, 3. So it's pentene. It's 2-pentene, but I don't like that. It's not wrong, I just don't like that. It's pent-2-ene. I think that's way better. Because of this. Look, pay attention, pay attention. What do you call this? What do you call that? This is 1, 2, 3, 4, 5. It's pent. There's no alkene, it's all single bonds, pentan. But it's not a pentan with an E at the end, pentane. It's a pentan with a functional priority group, pentanol. So we could call this pentanol, but have to give it a number because it could be on 1, 2, or 3. From that side, 1, 2, or 3. It's on 2, so it's 2-pentanol. Again, I don't like that. I want you to write pentan 2-ol. Do you see I'm putting the number in front of the group? And here is why. Here's the answer of why. What the hell do you call this? What do you call that? So the top priority group is the alcohol, not the alkene, right? Alkene is less than all of these oxygen groups. So that is going to get the lowest number. So you're going to number it 1, 2, 3, 4, 5. But this thing is still going to be called not pentane. Instead of the A, an E because it's a pentene, right? And instead of the E at the end, it's an alcohol. It's all, right? So this is a pentene all, right? Now the real whole point. If you're going to drop a number in front of the whole name, how are you going to number this? How are you going to number this? What are you going to say? There's something on 2 and 3? It's a 2 and 3? Like which one's on 2 and which one's on 3? How about you do it this way? Pent dash 3-ene dash 2-ol. Do you see I put the number in front of the group? Do you see how much more easy it is to figure out where things are and not ambiguous and strange. And I hope you're agreeing with me that putting the number in front of the thing you're talking about is way better than putting the number in front of the whole name. That's going to be confusing later in orgo. Of course, there's no way you could have seen that until we start combining groups, right? There's only one possible other question you might have. How do I know oxo versus oxo? And then, of course, you could just practice this. But how do I know oxo versus oxo? Think of the name. Let's say I had a carboxylic acid, and on the chain I had a ketone, and on the chain I had an aldehyde, right? I am going to name this now. That's an aldehyde, that's a ketone, that's a carboxylic acid, that's the top priority. So I'm going to circle the parent chain, including the top priority group, right? Number it from here, 1, 2, 3, 4, 5, 6. This chain is a hex and it's not carbon-carbon double bond, so it's not hexene, it's hexan. Oic acid, right? Hexanoic acid. Now on 3, there's an oxo. And on 6, there's an oxo. And then you combine them and you write 3,6 dash dioxo. And then, of course, if I was going to alphabetize, I wouldn't alphabetize according to the D for dioxo. I'd alphabetize according to the O for dioxo, right? Because di is a numerical prefix. You're with me? But 3,6-dioxo hexanoic acid. So here's the thing to consider. If you're a little tired, you're going to miss it. There's 2 oxos on here. Let's say I didn't see this picture. Let's say you read the name and you read 3,6-dioxo hexanoic acid. How are you going to know that one of the oxos is a ketone and one of the oxos is an aldehyde? It's so easy. Hex is the number of carbons. There's 6 carbons. And if one of the oxos is on position 6 of a 6-carbon chain, it's at the end. And if the oxo is on position 5, 4, 3, or 2, then it's not on the end, it's more internal. Internal is ketone, external end of the chain is aldehyde. Do you follow the idea? Yeah. So you could differentiate between aldehyde and ketone from the name. You know what I'm not going to teach you? We've spent a lot of time converting the structure to the name. I'm going to spend 0 minutes converting the name into a structure. In order to know something, you have to know it forward and backwards. Anything a human being knows will be, if you truly know it, you know it forwards and backwards. What do they do if they pull you over for drunk driving? The first thing they ask you is to recite the alphabet backwards. Because anybody who drives a car passed the written test, and if you pass the written test, that means you're literate. And if you're literate, you know the alphabet, and anyone who knows the alphabet can figure out how to recite it backwards. And if you can't figure out how to recite it backwards, you must be drunk. Because you know the alphabet, is what I'm saying. So you can't say you know nomenclature if you could only go in one direction. You're supposed to be able to go in both directions. Why won't I spend any time going from here to here? If you go from here to here, it's a joke to go in the other way. Just work the name backward. Okay, I'll spend 1 second. Watch how you work the name backwards. Just work it backwards. Don't even copy this down. Work it backwards. Forget the substituents for a second. Hex, 1, 2, 3, 4, 5, 6. It's a carboxylic acid, so obviously you have that. And then number it because it's your chain. I started here, so this is 1, 2, 3, 4, 5, 6. On 3 and 6, there's oxo. Oxo means double bond O. Draw the parent and then drop in substituents. It's so easy to go in that direction. It's much more difficult to go from here to there. So practice this. Be an expert of this. Start with the questions in the end of the chapter. And you're not good if you can do them. You only at a beginning if you could do them. We really need to be able to name anything I throw on the board. And some things are going to get all sorts of nasty. Now, why don't we do this? Why don't we copy this? Take a picture of it. Take out your phones and you'll take a picture of this when I'm done drawing it. Yeah, something that simple. And that actually is simple. See if you can figure out the name of that. That problem alone is going to bother you. Something about that's going to bother you. See if you can work through it. You'll see, if you don't see it already, you're going to see as you do this problem, you're going to be like, wait. You're allowed to email me and ask. I won't reply at all, but you're allowed to email me and ask. Thank you for your participation. Smash the like button.